So I think a little bit of time just thinking about this question is important, not just jumping straight into it. There's like um inverse no, there's proportion going on here, isn't it? Because the more people do the task, the quicker you're going to do the task, but actually the less time it's going to take. So that's the inverse proportion aspect. So I wrote down like a kind of intuitive formula that the amount of work done is going to equal the rate at which people work, one person, two people, three people, multiplied by the time that they're working for. And that means the rate that they work is going to be the amount of work completed divided by the time that it takes them. So I let the amount of work done equal 1. You know, it's just the full amount as such. It could be anything really. And then the rate is going to be 1 over the time taken. And then I'm going to say that Saba works at a rate of S, Ryan at a rate of R, and Darren at a rate of D. So then I can construct some equations. So when all three work together, so that is going to be S plus R plus D, their rate is going to be, it took them 5 minutes, so it's going to be 1 over 5. Okay, and I've constructed an equation. When Saba works with Darren, it takes 7 minutes. So S plus D is 1 over 7. And then Rayan and Darren, 15 minutes. So 1 over 15. We want to know how many minutes does it take for Darren to complete the task on his own? Well, we can use these equations. This is going to be an absolute crucial one because it's with all three in. But if I subtract, okay, the first one, so the first one minus the second one, then I'm going to get that R is equal to 1/5 minus 1 over 7. I'm going to work out the rate at which Rayan is working. Okay, put them over a common denominator. It's going to be 7 over 35 minus 5 over 35, which is 2 over 35. That's the rate they work. Actually, the time that they would take to do it by themselves would be 35 over 2, or 17.5 minutes. We're not asked for that, but we could work that out. Right, now I'm going to work out 1 minus 3. This one's 3. Because then I'll get, I've forgotten the name, Sabas. So I'm going to get S by itself. S is 1/5 minus 1 over 15, which is going to be 3 over 15 minus 1 over 15, or 2 over 15. And Saba actually will do the work in 15 over 2, or 7.5 minutes by themselves. Again, not actually, not required in the question, but I'm just saying. Right, so finally, we can put these in. We've got 2 over 15. I'm now replacing these in equation 1. 2 over 15 plus 2 over 35 plus Darren's rate is equal to 1 over 5. Okay, how best to do this? Well, I think I'm just going to do one at a time. So it's going to be 1 over 5 minus 2 over 15, which is going to be 3 over 15 minus 2 over 15, or 1 over 15. Okay, so then Darren's rate is going to be 1 over 15 minus 2 over 35. Okay, we need to find the lowest common multiple of 15 and 35. This is 3 times 5, and this is 5 times 7. So if I times this one through by 7, that'll give me 101 over, or 7 over 105. I times this one through by 3, give me 6 over 105, then I'm sorted. 1 over 105. And that is Darren's rate, 1 over time. So the time is going to be 105. It would actually take Darren 105 minutes to do the task by himself. E is the answer. There's other approaches to this. Have a look at the answers. They kind of do one in the extended solutions. I think they do it kind of different, similarly, but they write it as 1 over s. And then some other solutions I've seen to use a different approach again. But I quite like this. It works well, and hopefully it makes sense.